Ethics Fast
Connections
team.
We're a team of professors and undergraduates from Duke's Pratt School of Engineering
and the Kenyon Institute for Ethics, who work to answer the question,
how can we ensure that ethical considerations are prioritized during the engineering design process?
Engineering 101, Duke's innovative new first-year engineering design course, presented an exciting opportunity to challenge students to consider the ethical impact of their designs. While standard engineering programs across the country rarely address ethics until the penultimate year of study, students will now begin tackling some of today's most pressing questions related to engineering, all in their first semester at Duke.
Our team designed and tested modules to be included within the Engineering 101 course. These modules created space for students to consider the impact of their ideas at stages of the engineering design process.
We began the process of designing these modules by studying ethics and debating the merits of classic philosophers like Kant and Mill. We spoke to engineering professors from other universities to learn how they successfully integrated ethics into their engineering curriculum. We interviewed professors and previous Engineering 101 students here at Duke about their own projects and experiences with making decisions. We designed a survey that measures students' ethical attitudes at the beginning and end of the course.
Finally, we created 4 modules and piloted them in this spring's Engineering 101 course. Each module relates to a different stage of the design process, a systematic method to create a product which the course follows in a chronological order.
The first module focuses on systems mapping. Students identify the people, social, political, and economic issues, and materials and products involved in all aspects of their team projects and analyze how they are all interconnected.
The second module is a pairwise comparison chart activity. Students look at their design criteria and re-examine them through an ethical lens. Students watch videos that we produce that provide examples of ethical dilemmas previous teams faced in the course and how compromises and trade-offs were reached. Students then participate in a guided discussion activity about their own design criteria and how they would prioritize them as a team.
The third module is a competitive, interactive game show style activity about product testing to help the students think about the ethics of testing in a fast-paced, engaging way. Testing is the process of ensuring that the created device matches multiple different criteria before being released for use. Following the game, students complete an assignment that asks them to consider different points while testing their product. These include durability, efficacy, the necessity of IRB approval, and the ethics of testing on potentially vulnerable populations.
We also determined that an ethical mindset in engineering doesn't just mean considering your impact on other people, but also your impact on the environment. So we designed the fourth module to be the game of life cycle. The students venture through 5 stations of activities to help them think about the environmental impact of their building materials. Each station aligns with a step in the product life cycle, which is a high-level concept touched upon in upper-level courses. Students learn to take the view of different stakeholders while performing a skit about a simulated EGR 101 project. They complete a choose-your-own-adventure game to compare the utility and environmental impact of different materials for each step of creating a hand-washing station. And they hold a funeral for the device they created to think about how their product will be disposed, recycled, or reused.
In conclusion, our project aimed to empower engineering students with an ethical mindset to help them one day become ethical engineers.